Boxplots. But our focus is on our next lesson. We will compare two quantitative distributions. As such, or in preparation, we will study today graphical representations to help compare. So that's basically our whole focus, is that we're using today to really help set up Monday. All right, so that Monday we can just focus in on the comparison part, which is a big piece. Most AP exam questions are either one of two different things. On the first question, it's either to describe a distribution, or it is to compare two distributions. Now, to do this, of course, we have some you know, graphical representations that we have for each other. So, in terms of their basic versions, basic comparison graphs, that there's really nothing special to them. When I mean basic, I mean that there's nothing like really like that goes above and beyond. We have the dot plots, and we have a histograms. Typically, these are just drawn. They're just, you do them individually. There's nothing that you really have to do. So you might have your dot plot. And then you have your number line, blah, 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 blah. And then you might even have another dot plot here. With some data. Or you can have a histogram, same idea, and you have that information, and you might have the other histogram or dot plot drawn above and below. So they're basically, when we're talking about a histogram or a dot plot, and you're not going to see any of those in tonight's homework problems. You'll see them on Mondays. They're just two dot plots. There's just it literally looks like two dot plots, and just two histograms. Now we will use these on Monday. So I could ask you to describe each of them individually. So describe, distribution 1, it'll be context, of course. Describe distribution 2, describe distribution 1 for histogram, describe distribution 2 for the histogram. I could ask you that. And you might see some questions on that when you're just describing a singular distribution. And so that's when we do SOCs, shape, outliers, center spread. You're going to get some more practice on those tonight, and that's really, it's a very important thing that you get those done right and you feel comfortable with them, especially as we move into Mondays. So nothing really big in terms of properties. If you're trying to do, basically you would be given these dot plots, you would be given these histograms. Parallel box plots. Now, parallel box plots are a little bit more technical. The biggest issue here is that we have to label each, and they go on the same number line. So it is not just two box plots. It is kind of like two box plots, but the way if you just drew two box plots, you're not going to get credit for parallel box plots. And of course, you must identify, which means show work for outliers on both. So you have to check, you have to create an upper lower fence for each of them. An upper lower fence for the first box plot distribution, and upper lower fences for the second one, and identifying if there's any outliers for both distributions. But when you draw it, you're going to have your number line. You're going to have your who. You're going to have your what with the units. Now, the important part here is that when we're doing these comparing of distributions, the variable is the same. So we might be studying heights, but we might be doing heights for males and heights for females. So that's the two box plots. So you need to create a box plots for the female heights, and then you need to make a box plots of the male heights. Now the variable is still the same variable for both populations. So we're still talking about heights, and then also the same units, inches. However, one of them will be for just the male population, and one of them will be for the female population. And so when we draw them, we'll find the 5-number summary, and we would say something like, this is females, and then we would do it for the other population. And this would be for the males. It's important that you label who is who. And that's as far as I really want you to be able to have to go to in tonight's lesson. Making sure you making sure they're both above the same number line on top of each other. So the problem says to create parallel box plots. Now, remember, don't forget to check for outliers. All right. And I get it. I'm going to redo this. I'm going to do the solutions by hand to show this as well. So when you see my solutions on Monday for tonight's homework, you'll see. Well, I think I did. I think I have to. You have to check the work for outliers. You can't just assume that there's no outliers, or you can't just assume one of the values is an outlier. So biggest thing, most important thing, label the two box plots of who they are talking about. And secondly, you draw them on the same number line. All right. So the same number line, the same scale, one on top of the other. You can draw them, of course, vertically, as you'll see, that you saw in your homework solutions. It's all good. Any questions? Okay. Last part of today's lesson, side by side stem plots. And remember, when we say stem plots, we used to call it stem and leaf. With the side by side, they use the two distributions, use the same stem, but own leaves for data values, and therefore also the same key and scale. So I feel for the most part, the majority of you, if I showed you a stem by stem plot, you would feel comfortable looking at it by now. But I want to be very, at least somewhat explicit in an initial lesson of what they look like. So when we draw a stem plot, we might have something like so in example, in a stem plot, we would say, of course, you know, 5, 6, 7, 8, 9, and then you might have, um, 4, 5, 6, 9, 0, 0, 1, 2, 3, 8, 9, 0, 0, 0, 1, 4, 5, 8, 3, 9, 9, 9, 9, 9, 9, 9, 0, 0, 0, 1, 2, 3, 3, 4, 5. And this would, we have, who that we're talking about here. This may be for, males. And 5-4 for my key is equal to, we'll say 54 points. I don't know what, I'm just making up in terms of these type of numbers right here. Now that's what a stem plot would look like. So this so far looks like a normal stem plot. Nothing different. I can ask you to describe this stem plot. This stem plot, or describe this distribution using this stem plot. So this distribution would be, looks unimodal and skewed left, because the lower values has the little tail out, it tails out to the low values. So I would say skewed left. I can say that this data is probably centered. I can actually plug in the numbers and find the median, but I could probably say it's somewhere in the 70s. The median, I can actually calculate using the n plus 1 divided by 2 term. I can find the median. I can see that most all of my data, it's kind of very well spread out here. So I would even say, my data, pretty much is from 54 to 95 in regards to the spread. Now, what makes it a side by side? You put a stem line on the other one. And here is where you do the females. And you might be like 1, 1, 2, 3, 4, 8, 0, 0, 1, 3, 9, 5, 0, 1, 2, 2, 3, 8, 8, 9, 9, 9, 9, 0, 0, 1, 2, 3, 5. Now, in regards to the females, the female distribution looks uniform. All right. So males are unimodal and skewed left. Now, this is mostly for Monday. And females are roughly uniform, blocky. But this left side is what makes it a side by side. So you're just using the same stem. Questions?